Hello everyone. In this video, we will be discussing a very important derivation. From exam point of view, it is very important. Just pay your attention and I will tell you how to derive this derivation. The name of the derivation is torque required to raise the load. Here you can able to see this. I have taken only one thread and where one lead only I have considered. You can able to see this only one pitch I have taken and the helix angle is formed and the distance of the screw have taken that is the diameter is nothing but circumference is nothing but pi d. The front view only I have taken and you can able to see this for a load which I have to raise means where let me assume that P is the applied on the nut. You can able to see this where this is a load and I want to raise this load towards upward direction on the nut, and for one complete revolution of the nut the screw will move axially in axial direction. The screw will move. You can able to see this is the P where the load which is the effort which is applied to uplift this particular load. The forces acting on the thread profile are shown in the figure. You can able to see this when this is the force applied means, and here you can able to see this there will be a mu Rn, that is the frictional reaction force will be there in the opposite direction because it tends to move towards gravity. So there will be a frictional resistance force, that is mu Rn, and since this angle, this P is applied in x direction, that should be inclined to the axis of the load. So that is a P cos alpha, and the other side will be P sin alpha. And similarly, we have a normal reaction perpendicular to the axis of the load we are lifting up, and there is a weight which is always towards the a positive x direction. After resolving that, you can able to see this for the x-axis it is w sin alpha, and for the y-axis w cos alpha. So this is the very important loads which is applied or acting on this particular screw when the torque is applied to raise the load, and we need to remember this resolving forces in the correct directions. For the forces acting on the thread profile as shown in the figure, and resolving these forces along the plane of the thread profile where clearly it is shown. So let me consider only the x-axis force and later y-axis force. First we will see the summation of all the x-axis force, let me take, which is equal to 0. So all the x-axis force you can able to see, we have P cos alpha, we have W sin alpha, and we have mu Rn. You can able to see only this P cos alpha is acting on the plus y direction, so that is only plus. This W sin alpha and mu Rn is acting in minus x direction, so it is minus, which is equal to 0. Now taking these two terms to the right hand side, so we will get P cos alpha is equal to W sin alpha plus mu Rn. Similarly, let me consider the vertical forces. So what are the vertical forces I am having? I have a normal reaction, and I have a P sin alpha, and even I have W cos alpha. So you can able to see this the load which is applied in the positive y direction should be considered as positive, and here it is a negative y direction, that should be considered as a minus sign. So let me write this all the vertical forces, that is a summation which is equal to 0. So plus Rn minus P sin alpha minus W cos alpha, which is equal to 0. So keeping the positive sign in one side and all the negative side taking to the other side, so that will become positive. So P sin alpha plus W cos alpha. Let me write the horizontal resolving forces as equation 1 and vertical resolving forces as equation 2. Now let me substitute the equation 2 in equation 1. So what I will get, P cos alpha is equal to W sin alpha plus mu of P sin alpha plus W cos alpha I will get. Then the next step, let me take this mu inside. So W sin alpha plus mu P sin alpha plus mu W cos alpha I will be getting. Now I will be segregating the sin terms on one side and the cos term on another side. So since already cos alpha is there in left hand side and right hand side I have one cos term, I will be taking to the left hand side. So what I will get, P cos alpha minus mu P sin alpha, which is equal to W sin alpha plus mu W cos alpha, where I will be getting a P of cos alpha minus mu sin alpha, since P is constant. Instead of taking the common cos and sin, I have taken the load, and that is P and W on one side. In that way also we can able to take. So P into cos alpha minus mu sin alpha, which is equal to W into sin alpha plus mu cos alpha. So keeping P on one side, taking all the terms to the other side. So W into sine alpha plus mu cos alpha divided by cos alpha minus mu sine alpha I will be getting. So this can be written as a tan phi. What is tan theta? Tan theta is nothing but sine theta plus mu cos theta. Similarly, this mu, the coefficient of friction is nothing but tan phi, which is nothing but sine theta by cos theta. So let me substitute this mu here. So sine alpha plus mu is sine theta by cos theta. So cos alpha. Similarly, cos alpha minus mu is sine theta by cos theta. So into sine theta. So everything, let me take it. So sine alpha into cos alpha. Let me multiply cos alpha everywhere. Sine alpha into cos alpha plus sine alpha into cos alpha divided by cos alpha, and cos alpha into that means taking this LCM this side. That is the meaning. So cos alpha into cos alpha minus sine alpha into sine alpha divided by cos phi. So this one after cancelling, because cos alpha, cos phi get cancelled. So I'll be getting P equal to W into sine alpha into cos phi plus sine phi into cos alpha divided by cos alpha into cos phi minus sine phi into sine alpha. So finally I'll be getting this equation as sine of a plus b divided by cos of a plus b, because sine of a plus b is nothing but sine a cos b plus sine a sine cos b. So that formula I'll be using, and finally I'll be getting this one, and we know that sine by cos is nothing but tan. So finally I'll be getting P is equal to W into tan alpha plus phi. So this is the torque required to overcome the friction between screw and nut. That is T1 is equal to P into dm by 2, and T1 equal to W into tan of alpha plus phi into dm by 2. When the load is taken by a thrust collar, so that the load should not rotate with screw, then the torque required to overcome the friction at the collar is T2 is equal to 2 by 3 into mu1 into W into R1 cube minus R2 cube divided by R1 square minus R2 square. So this is the formula we are supposed to use for the uniform pressure condition. When we solve the problem where they clearly mention whether it is a uniform wear condition or whether it is a uniform pressure condition. In case if it is a uniform wear condition, means the formula is very simple. That is T2 equal to mu1 into W into R. We have to use this one. Again, if you have a doubt with what is this R means, we know it is the average of R1 plus R2 by 2. Therefore, the total torque required to raise the load will be capital T is equal to T1 plus T2. That is T1 is nothing but W tan of alpha plus phi into dm by 2 plus T2 is equal to, either we can go with this one or this one. If I am going with uniform wear mix, plus mu1 into W into R1 plus R2 by 2. So this is the equation we will be getting for the torque required to raise the load. Similarly, for lowering the load, that is the torque required to lower the load, the same like the sketch only we will be taking. Again for the one thread only we will be using, again for the one lead only we will be using. But what is the difference here is, here the load we are trying to lower down. It means like the frictional force will be in the opposite direction, and remaining the applied force will be in minus x direction. That's all. Only these two changes, and remaining things remain same. That is the reaction force in 90 degrees, and even the W also will be towards the positive y direction. That is the gravity direction. It will be there. It will be there. So in the next video we will see how to do that. Thank you.